Ridgefield's Inland Wetlands Board holds its third hearing on July 13th, 2023, on a very controversial application for a project at 27 Abbott Avenue, adjacent to a very sensitive wetlands and flood area, on .44 acres, 14 apartment units over garages. This kind of density in this location raises legitimate public concern and tests the Inland Wetlands Board's authority to protect this environmentally sensitive and valuable resource.
The Thursday, July 13th, 2023, regularly scheduled meeting of Ridgefield's Inland Wetlands Board. In attendance, we have Alan Pilch, Carson Fincham, David Smith, Chris Phelps, Tim Bishop, myself, Susan Baker, and Caleb Johnson, Wetlands Agent. And is that everyone? Yeah, it looks like it. Okay. So, as you know, we have two continued public hearings. So we will get to the first one. Caleb, if you want to promote the various people who will be speaking. Tracy Miller just joined. Hi.
Hello.
And since we have a very full agenda this evening, we have two public hearings, as you know, and last meeting went a little too late. So we are going to aim on the first one for a hard stop at 8:30. And hopefully that'll break down to an hour for peer reviewers and responses and our questions, and then half an hour to go to the public. And I'm imagining most likely we will need to ask the applicant to grant us an extension, because as you all know, we're just getting started with our peer review presentations. And we are still, as of today, we got some new information from the applicant. So we're in the thick of it and we'll just try to move things along. So at any rate, IW 23-18, 27 Abbott Avenue, plenary ruling application for construction of apartment complex, associated parking and drainage infrastructure within the upland review area of wetlands. Owner Alimi Viton, applicant Brian Carey. And just a little other housekeeping on this. I just wanted to mention, since it has come up, that we did look up our previous versions of the inland wetlands regulations. And just for the record, in 2005, the wetlands upland review area was 25 feet. In 2018, it changed to 75 feet. And in 2020, it changed to 100 feet. And the previous approved application for this site was approved actually right before the change to 75 feet, although it looks like that was anticipated since the maps show that. And in fact, that is not due to expire in October because of a rule that came up during the COVID, and everyone who had an open application at the time got granted 14 years from when it was approved. So approximately 9 years left on that previous application's approval. So, but at any rate, all that said, the current application is being heard under the current inland wetlands regulations and will be considered on its own merits rather than in comparison to earlier decisions, applications, whatnot, just so it's out there. So we have two peer reviewers, and I guess we could start with the biological peer review if we have.
Yes, I'm adding them right now.
Chris, yeah, Chris Sullivan. Hello.
Hello, how are you?
Very good. Thank you for your work, and please proceed with your presentation, if you would.
Sure thing. Thank you, Chair Baker, for the opportunity. My name is Chris Sullivan. I'm the Executive Director of the Southwest Conservation District. We're a natural resource-based nonprofit that works with 43 municipalities across New Haven and Fairfield County. Both myself and my colleague Courtney Gilligan, who worked on the document, have gone through the CTDEP wetlands agent training. Before I was at the district, I was at DEP for 11 years in the Water Bureau. And Courtney has also gone through the Qualified Compliance Inspector Stormwater Program from Stormwater 1. And the Conservation District is permitted to do stormwater inspections for solar panel arrays through our service area. So just a little bit of background on the organization, some of our credentials. And I'm glad to provide some input and feedback on the application that is before the commission tonight. I'll just walk through kind of a summary of the recommendations packet that we did submit to Agent Johnson and the commission earlier this week. We did visit the site, 27 Abbott Ave, on June 13th and walked the property. Sort of a summary of what we put together was a series of resource maps from the NRCS Web Soil Survey, looking at hydrologic soil group, depth to stormwater, some things like that. We also utilized the StreamStat software to delineate the watershed area that's flowing into the property, and we included information detailing the land use in the surrounding neighborhood and the watershed flowing to the property. Just a couple of, I'm just going to extract out a couple of points that I wanted to call attention to. We did note that there was a discrepancy between the E-letter for the Natural Diversity Database and then our GIS mapping that we did showed that there could be some species on the property. So we did send a note to Agent Johnson about that discrepancy, and I believe that was forwarded to the applicant to follow up with that at Connecticut DEP. So I just wanted to make a note of that here. A couple other comments and recommendations that we had for the site. We did look at the property, make a note of the existing habitat, which is basically a grass lawn. There's a proposed buffer for the site, which would improve the diversity and also improve habitat for species and improve filtration coming off the property. We did recommend some invasive plant removal. We noted garlic mustard and bittersweet in the property and suggested some sort of management plan as part of an approval for the buffer area so that it doesn't get overgrown soon after it's planted. We also made a recommendation of using a tree box filter on the property instead of a hooded sump on the northern edge of the driveway adjacent to 25 Abbott Ave. And that could then still be piped into the Cultex system. This would just give a little bit more treatment, probably a little bit more aesthetically pleasing for the property, but it would treat that stormwater coming off the driveway and going in through the tree box filter a little bit better. We did also recommend in the buffer planting at the edge of the property, directly upland of the wetland, to change red maple to maybe a swamp oak or a river birch. And there's a couple other things to plan. This was mostly because there's a lot of red maple observed in the area already, so this could increase some diversity of the tree species on the property or the adjacent wetland area. Probably the biggest thing that we noted was dealing with the infiltration on the property. We did note the soil category of a C to D. We thought that the perk testing looked pretty good for infiltration rates and appreciated the conservative margin of safety that the applicant utilized. We have been starting to look at the draft stormwater manual that Connecticut DEP is reviewing and preparing to release, and they do recommend some additional infiltration testings in those soil categories, which were recommended in our document. And then, you know what, I didn't write that down on my comments, but just to further be sure that the infiltration systems are going to operate as designed in this soil area, which, what we want to do is make sure that it is treating the stormwater off of the property and the buildings and protecting the adjacent wetland area. So we do recommend kind of going with some of those additional test methods, knowing that draft manual is still draft, but it is going to be what will be included for these types of soil categories moving forward. And then the remainder of our document did include some recommendations for the neighbors and other property owners. It did seem like there's a lot of concern for the wetlands, and so we made some recommendations that other people could be doing on the property. Obviously, that's not part of your approval, but we just wanted to include that as on the record so that folks could take other actions in the adjacent property lots to help benefit that intermittent stream and wetland system. That's a super quick and short summary. I hope that helps stay within your hour-and-a-half window for this hearing. I could try to answer some questions if folks have anything. You're muted.
Thank you. If we could briefly step back a minute. I'm sorry, we had some technical difficulties and I forgot to ask Caleb if he would read new documents into the record.
Yes. Okay, so for correspondence, emails, and letters, there's 63 in total. 622-2023 site plan, alternate site plan, 622-23 drainage report, Steve Trinkus response to comments letter, 622-23 aerial, 10-3 2018 approved site plan, 27 Abbott wetlands permit 2018, the engineer peer review report, Steve Trinkus response to the Artel engineer peer review report, OM report dated 7/10/23, drainage report dated 7/10/23, site plan dated 7/10/23, comment response letter to Artel, biological evaluation peer review report, land tech response to biological peer review, and final wetland standard analysis memo.
Thank you. I'm very sorry. Neglected that. Okay, Chris is finished. Questions? Okay, Alan.
Well, Tracy was before me, but if you'd like.
Well, you're
Okay.
on the left in my screen and
Okay.
that's why I called you first.
So I guess, Chris, I have a question for you. This plan proposes a wall along its northern property line on the east side of the property, connecting into the southeast corner of one of the townhouse buildings. So is there any concern on your part of creating a wall/bathtub on this property, which then disassociates a good portion of the upland review area from the remainder of the wetland? Because that's a concern of mine. We don't usually encounter sites where you physically wall it off so that there's no, so as much as you might want to tell me that you're planting portions of the upland review area above the chambers or even below the chambers, nevertheless, there's a physical separation between it. And that physical separation is large. So that's a concern that I would have.
I'll be honest, that's not a component that we really dug into too much. We were mostly looking at the sort of plants that were recommended. I agree that there could be a bit of a separation from the stream and wetland area. I don't really have a strong feeling on that one way or another. Sorry, that's probably not a greatest answer for you, but it's not something that really jumped out at us as a concern as we were reviewing it.
Okay. That being said, it's a concern certainly of this member of the board.
Tracy?
Okay, thank you, Chris, for your analysis. It was really, really helpful. I just have two questions for you. I think you also recommended a 50-foot vegetated buffer. Is that correct?
I think that was in the end of our conclusions. Let me just open the document so I don't misspeak. As an ideal situation would be great. Let me just make sure I'm reading that correctly.
So just some feedback from you on what makes that ideal, I think would be helpful. I can think of a couple of really good reasons, but I'd like to hear from you.
Yeah, I think that extended buffer area just gives more potential treatment of any surface flows that would go across the property. It does give a little bit better habitat for the upland area for any sort of things that are using that wetland system. It's also going to be better for any sort of potential natural regrowth or reseeding of the native plants or other wetland species plants that are not just planted in the new buffer area, but they're already growing there. They could spread into that area a little bit more. So that's kind of an ideal thing. And I think we actually referred to a fisheries document that talks about that buffer zone width as well as being a recommendation from DEP.
I think you did. And also just simply because of the amount of impervious surface, I think it's a wise recommendation. And there's also a rather large red maple that's casting a lot of shade on the wetland and stream. And that 50-foot buffer would actually protect the root system of that maple. So I think that would be another good reason. And I'm sorry, I forgot to introduce myself. I'm Tracy Miller and I'm a landscape architect. I live in Ridgefield. And then just my second question, you also recommended, you mentioned this, another percolation test. I think it was the double ring infiltration test. And the other peer reviewer also recommended that test as well. And so just a little bit of feedback on why you think that would be an important additional test.
So the biggest reason is that the soil category, the soil hydrologic soil grouping comes about mapping as C and D. So potentially the infiltration rates aren't necessarily great. As I mentioned, the draft stormwater manual also recommends doing these further infiltration tests. So in theory, moving forward, that's what projects in this type of soil grouping are going to be doing. And those additional soil tests, and it doesn't have to be the double ring. There's several things that are listed in that draft manual as acceptable approaches. I could read them to you if you wanted, or I could share that copy. But the biggest thing is that it gives a better indication of kind of up and down movement for infiltration as opposed to more just laterally. So in an area where there's a significant amount of proposed infiltration to treat the stormwater leaving the site, we just think it's really important to make sure that it is going to work as designed.
That's great. Thank you. Just one follow-up question to the draft stormwater manual. I think it was written in 2023. And so do you think it makes sense that a stormwater manual written in 2023 might be practical for a project today as opposed to the 19-year-old 2004 manual? It just to help me understand.
Yeah, in my opinion, I think it's a much better document. Technology and practices have changed dramatically in that 19 years.
Okay.
And so it's just there's more tools available for handling stormwater leaving properties, and there's a better understanding of what works and maybe what doesn't work. While it's not regulatory or officially adopted by DEP now, it seems to be that's the direction that the document is going. So we think that it's a better recommendation for projects at this point.
Thank you.
Sure thing.
Anyone else on the board? Questions? No? Nothing else at this point? Tracy, your hand is still up, so I don't need to. Okay, anything from the applicant at this point in response?
Can I actually ask?
Sorry, I think we'll just wait to respond to all the questions from the engineering review too at the same time.
Okay, that'd be fine. Okay, so at the moment, then we should call up Mr. Varekis.
Good evening. For the record, Dinas Verbicus, professional engineer. And I've been asked by the town to act as a peer reviewer of the proposal. We had some time ago provided comments to the second iteration of the plans, to which it appears that the applicant has addressed those comments to a degree. We haven't dug into it deeply, but it seems like they've addressed everything that we've touched upon. Kind of jumping in where the conversation with the prior presenter left off and the infiltration. We too had a concern about the infiltration of the water into the soils, but based on the soils depicted in the test hole information, the soils don't seem to jibe with the soils that are listed on the web soil survey. it indicates on the web soil survey that most of the soils on site are Woodbridge soils, and with Woodbridge soils, you would normally find redoxamorphic conditions or modeling and or groundwater at elevations of 16 to 18 inches below grade. And here on all 4 test holes, groundwater was noted to be quite a bit deeper than that. So I suspect that perhaps the soils that are on site may be the result of filling, or perhaps the web soil survey is a little bit off on it. So, but the applicant designed their system based on the percolation tests attained, and the stormwater management system that they are proposing will be, for the most part, set all in fill material. We had in our review questioned, because this stormwater management system will be encircled, well, the entire site will be encircled by walls. We question what would happen to the water in this treatment system if all means of it to exit the site are blocked off. And the applicant has proposed weep holes at the bottom of their proposed retaining wall, which in effect would allow the water from the stormwater management system to flow subsurface and continue through the soils onward off the site and toward the wetland eventually. We recently downloaded, I guess a couple of days ago, we downloaded the updated drawings, and they seem to indicate all the responses that they had made to our comments. They had added to the design drawings. So on the first blush, first glance, it does not appear that there's anything more of a showstopper type nature that we would find on this application. Although one thing that embarrassed that I missed to pick up on, and it's not shown on any of the drawings, is the water source for the building. Granted, it's not a wetland related item, but there's no indication as to how water will be provided to the site. We did note on going through the neighborhood, there are fire hydrants, so we suspect that there is municipal water available, but yet nothing shown for the site. So just something that the applicant as well as myself missed on the review. But I'm happy to answer any questions that anyone might have regarding the site related elements.
Okay, Tracy?
Just one question, just following up on the same question that I asked the last peer reviewer. Do you think the double ring infiltration test would be a good test to implement as a test of precaution?
I think that it would not hurt to do a double ring test, but again, it appears to me like the soils are not necessarily what is indicated in the web soil survey, or again, maybe the Woodbridge type soils are perhaps located down beneath fill materials that may have been placed over the years on this property. So I don't think it could hurt to do it. Okay,
and you felt that the depth of the soil tests was adequate?
Yeah, so the percolation tests that were conducted were all, they're indicated to all have been at a depth of 30 inches down, which if these were Woodbridge soils, you would have been in groundwater more often than not. But they did not, they did not encounter groundwater, and in the test holes, to my recollection, it had indicated that groundwater or models, indication of groundwater. It was noted at about 46 inches down below grade, give or take, to my recollection. So we're quite a ways down. And the proposed stormwater management system appears to be designed so that it is at least 36 inches above that elevation. So there's a part of it that's notched in about 10 inches to a foot into existing grade, but most of it will be, for lack of a better term, floating above the existing grade.
Okay, thank you.
Sure.
Alan?
Yes. Again, Alan Pilch, I'll just say that I am a civil engineer and a landscape architect. Mr. Rabikas, I also reviewed the stormwater report, and I had a couple of things that I would like to have you just sort of check over as well.
Sure.
One of my initial comments is that I agree with the Mr. Sullivan too, that a deep sump and hooded outlet is not an adequate way to ensure that fine sediment is trapped before it gets discharged into the chambers. And that's obviously a concern, since that would reduce the infiltration from the chambers, and
Sure.
and then that would impact, of course, the flows going into the wetland. So that's a real concern here. I also noted that in the drainage area that is conveyed, this is the buildings and the parking area. The drainage areas that was conveyed to the chambers had a time of concentration, which was, I think, not representative of what is actually occurring on that drainage area. The drainage area itself is 89% impervious, and it used I don't remember the exact number, but it was maybe like 20 minutes or so for the time of concentration. And I think in an impervious area like this, which is like 90% impervious, I think it's going to be a lot faster. And as you know, what that will do, of course, is increase the peak rate of runoff going into the chambers. So my concern is that the chambers are not sized properly for the anticipated flows that will actually be going to it.
Right, and I noted that as well, but and forgive me, I'm trying to go off a recollection, but from my recollection, I think that the area that that had that long time of concentration was actually just the surface runoff on the south side of the building. So when I looked at it and I questioned it, I thought, oh man, this is way longer than it should take. But I think there was a time of concentration of 5 minutes for everything else, all the paved areas and such. And again, it was just that one little sliver that goes from the west side of the site behind the building on the south side of the building all the way to the rear. So in a grand scheme of things, not likely going to make a huge difference at all to the sizing of the system. But I had similar reservations on the calculations. But I think in the scheme of things,
I think to and first of all, that drainage on the south side of the building through that sliver is going to bypass the entire system unless there's a drain there. It's just going straight out.
I think ultimately it's going to flow further to the south. It'll meander along the building and then pitch its way out to the south and make itself to the wetland or to the property to the south.
Right, but I think my conclusion was that it's the time of concentration is much less, and what happens when you decrease the time of concentration, it increases the peak flows, and I think the peak flows that were modeled are artificially low as a result of that inconsistency. That's a term I'll use here in doing the modeling. one of the other concerns that I had too was that I saw that, for example, in a 10-year storm event, that the peak water surface elevation in the chambers was actually above the invert elevation of the catch basin, that single catch basin. And so my concern is that there isn't a free discharge going on when the elevation of the water in the chambers is higher than the invert elevation in the piping system. And so that's a concern of mine too.
Okay.
And so it's
You
something
know,
that I think perhaps you could take a look at as well. It's like, I almost want to see like a hydraulic grade line showing what's going on during that storm event. Because my concern is twofold. One was that when I reviewed the analysis, the peak rate of the peak water surface in the chambers was higher than the finished floor elevation of the 5 easternmost buildings. So if that flow were to be coming up from the Caltech overflow orifice and
Right.
into the so-called bathtub created by the retaining walls, there could be a potential for that water to enter those buildings. And so that was a concern of mine too.
okay, we'll,
So this is something I'd just like to have you take a look at, because my review, these would give me pause when it comes to an overall design with respect to the stormwater. And as I say, I am a civil engineer and I do stormwater analysis a lot as well, so,
sure.
and
Sure,
design.
sure. And yeah, I'm just looking, for instance, right now on the underground detention system. I've got, while you were speaking, it appears that during a 10-year storm, the peak elevation in the underground detention is 202.49.
And the invert is 202.40. At the catch basin, that's what's being proposed. So to me, it's not really a free discharge down the pipe into the system. It's already been submerged.
202, yeah, let me just,
And
so, rather than hold
no,
up.
you have to analyze
I'll-
it now, but just
Yep.
take a look at it.
Sure,
That's
Sure.
that's all I'm requesting.
yeah, absolutely.
I know we just received these plans like a couple days ago, and I too have just had a brief look at it.
Right. Right, okay, I will certainly give that part a once over again.
Great, thank
to,
you.
yes, you're welcome.
And thank you for your review. I think it's most helpful. I really appreciate it.
Yeah, my pleasure.
Any other questions from the board on this? I only had one myself, since you brought it up. I'm not familiar with how weep holes work. Could you give us a quick explanation of that?
Sure, weep holes are just a physical relief for water that may become trapped behind an impervious surface. So if you look at a retaining wall, oftentimes you'll see some pipes that or holes in the wall that appear to be, like what the heck is this for? Those would be the weep holes, and they allow water that has been built up behind the wall to flow freely rather than apply excessive pressures to that wall. So it's just a relief valve for groundwater. And in this particular instance, the wall that the applicant has proposed, in addition to having the level spreader, which allows water from the stormwater management to escape, they did propose weep holes below grade, which would allow water to pass freely through the wall that's the portions of which are not seen.
Okay, so in other words, is to prevent the water from then basically coming up to ground level because it's hitting
Yeah.
the wall?
Yeah, exactly.
And-
Yeah,
And then spilling over.
that's correct.
Okay, but none of the water you're talking about in this case would be strictly groundwater and not water that was introduced from the roof leaders, any of these other
Well,
devices?
It may at some point become, a mixture of the water that goes through the stormwater management system as well as the groundwater. My initial concern, again, was the fact that for all intent and purposes, the site is going to be, well, I envision this site being constructed by first constructing walls all around at least 3 sides of the site, and then fill being brought in to place, and then, all the construction going on top of it. So my concern was that the stormwater management system, which was located and surrounded by retaining walls, would only function to a degree. And if ever that dirt or ground in the vicinity of the stormwater management system was inundated to the point that, total saturation, things would get awful. So the applicant again has proposed these weep holes to allow water to flow underground to points off the site.
Chris?
Yeah, hi,
Thank
I'm
you.
Chris Phelps. I'm a member of the board, and I'm sorry, my computer is broken, my screen doesn't work. For the two, Mr. Trinkus and Mr. Sullivan, I just have a question for you. Would this development be something that you would feel confident if it was next to your neighborhood?
Well, we can't talk with Mr. Trinkus until we get to the public portion, but we can certainly talk to him at that point. So we'll
Thank
put
you.
that aside, and
You got it.
Chris, can you answer?
Would I feel confident if it was in my neighborhood?
Yeah, I mean, like, would you feel like this is a reasonable development, something to do, given the parameters of the land, given the constraints of the neighborhood?
Yeah, I mean, this is obviously pretty opinion. I don't have a planning thing or anything, but it seems like the existing lot is just grass. So from habitat, that's not great. It's obviously going to increase the density on the lot in terms of the number of people living there, but that's not really a wetlands issue either. So, I mean, I don't know that I would be opposed to it. I don't think I would be concerned. And I do think that there's potential for improving the habitat of the existing lot, from the grass to better plants and other things on those ends, and potentially actually having better water leaving the lot going into the wetland system than what's coming off that grass lot as it currently is designed.
Thank you, appreciate it.
Sure.
Okay, Alan?
Yeah, sorry, I just realized a couple other comments I have. Maybe Mr. Rabikis could look at this as well.
Mhm.
One of the concerns I have too is the proximity of the chambers to the buildings. I know the 2004 Connecticut Stormwater Quality Manual recommends, the term I'll use, a separation of 25 feet. And I know here on this design, it's much less than that. And obviously it's to prevent some type of impact, the term I'll use, to the building, either basement, footings, foundations, whatever the case might be. So it's something I just want you to weigh in on as well. And
Sure.
one of the other, just to confirm as well, if you would, is there 3 feet of unsaturated soil in the design between the bottom of the chambers and the groundwater table? Because I noted in the deep hole testing, there was water flowing in at a depth of 4 feet. You had noted that too, but I just want to make sure because that's also a requirement. And
Correct,
finally,
correct. On the applicant's drawing sheet C 2.0, they have cross sections of the stormwater management system, and they indicate 36-inch minimum separation between the groundwater elevation and the bottom of the stone associated with the bottom of the system.
I guess the other question I have too, is for maintenance of these chambers. I know there's an inspection manhole that's provided. There's no detail on what that manhole means, especially when it's installed inside a Cultec chamber. I mean, typically the inspection ports are much smaller, and there are certain ways one maintains these chambers, and I just want you to just take a look at that too, just so that any buildup of sediment can be removed, because it's a fairly large parking area and one's always concerned with fine sediment and its detriment on future infiltration, because at 2 inches an hour, it's an important aspect of the overall modeling. And obviously my concern is that the modeling is not accurate. Will have impacts into the wetland through increased flows.
Okay.
So that's the concern that I have.
We will look into the maintenance element of that as well.
Great. Thank you.
You're welcome.
Do we have any other questions from the board? Okay, then we can go to the applicant, Mr. Carey. I know you have some responses prepared.
Yeah, so just for the record, I'm Brian Carey, Conservation, the head of the Environmental Services with Land Tech with offices in Westport. So basically, we did provide a written response to both of the third-party reviews. We just got the one from Chris Sullivan on Tuesday, so we submitted our responses this morning as soon as we could get them completed. So those are now in the record. We agree. The report. We agree with most of the comments in the report. Just to go through what Mr. Sullivan was saying, the NDDB request, we did reach back out to the DEP just to confirm. They did acknowledge that there is a little bit of a discrepancy there, but the issue being that there really is no habitat on the property in its current state that would be that would facilitate or basically harbor any state threatened or endangered species of concern, because the property is completely turf grass. So there really is no habitat that we've observed on site that would be home to any, again, any endangered or state listed species. So we feel that kind of resolves that issue. As far as, another comment that was provided was to switch out some of the plantings, the red maple, and add some additional shrub layer plantings. We have no problem with that. We're going to switch out the red maples with a mix of river birch, and we'll add another fern layer, install ferns in the shrub layer. That will help with additionally help with increasing the buffer, but also providing some cooling effect to the adjacent stream. So we have no problem with that. There was a question about invasive management plan. Basically, when we did our initial site investigation, we didn't really observe a lot of invasives because there is such a dramatic cutoff between the property and then the adjacent site where the wetlands are located. It really just goes from turf grass into into this wetland area. We have no problem putting together an invasive species plan. In management plan, it'll be pretty general, just because of the condition of the site. Garlic mustard is something that is easily removed, pulled by hand. It's basically only around for a very short period of time in the spring, and it goes to seed and then it will disappear. And again, bittersweet is obviously more long standing issue. If there's any volunteer invasives that come into the site after the project is planted, we will absolutely perform monitoring that as routine maintenance. The goal was really to just let the wetland buffer planting go without mowing. So we will, we'll make sure that that is monitored periodically, so that there is no colonization of, any unwanted invasive species there. I can put that plan together and submit it into the record. That is not a problem. There's been a lot of talk about about a double ring infiltration test. We're not necessarily opposed to doing that. It's not a lot of work, but we've always, percolation tests have always been done when designing stormwater treatment. So the double ring test is a higher level of standard that is commonly used in the industry. I know it's becoming more now that the new manual is in draft form. The DEP is recommending that. We don't think it's necessary, but again, it's not something we're gonna, it's belt and suspenders. It's not a problem. But we don't think it's really required. Just as far as the soil mapping, I think Artel Engineering kind of answered that question as we did, which was just saying that the soil mapping for the site, we did field level soil survey, soil mapping and investigations through the use of deep test pits. And we had our staff soil scientists, wetland scientists do the percolation in the test pits, and we agree that the soil mapping for the site is not indicative of the field conditions. So that's why we do test pits, because we don't rely on the soil mapping for all the sites, especially during design. So we kind of agree with that. We did submit an operation and maintenance plan for the site. That's been uploaded into the record. And then the final comment, really about the 50-foot buffer. Obviously expanding the buffer is important. We do feel there's an adequate buffer. That's why we've had it planted so vigorously. If there's work outside of the 50-foot, we wouldn't need to come for a permit. So the discussion about not having any work within a 50-foot buffer, I mean, that would just, if we were to do that, we wouldn't need to seek approvals from the commission per se. So we think, based on our professional opinion as a professional wetland scientist and as engineer, as Andy is an engineer, we feel that the buffer as provided, given that the current state of the property is in turf grass, is a benefit or an improved condition over what is actually there. We've taken great strides to landscape this in a natural way that will, again, increase the biodiversity, increase and expand the existing buffer from the lawn into a more appropriate cover type. So we feel that the buffer we have is adequate. And that's basically all I have in response. I mean, the Southwest Conservation District report, I think, is well written, and we agree with most of their comments. I think they're favorable. I think they did look at the project in a manner that we did, and showing that it is protective of the wetlands. Andy Semelides from our office was going to address the comments associated with the third party Artel's engineering review.
Okay, before we get there though, I just would like to point out that our upland review area is
100 feet. That's right.
Not 50. You'd still be in front of us,
Yes.
is what I went to say.
As soon as I said that,
Yeah, like,
Yeah.
no. No, and I did have a question as to the term adequate as opposed to another term, and we get it that the current situation is being improved upon, but we also get it that we're putting a lot of impervious surface here. So that's kind of we would expect certainly at a minimum adequate. And so I would like to kind of explore with you just for a minute, what do you mean by adequate? What does that tell us?
So in my opinion, the buffer as being provided, currently you have an area which is all lawn placed on top of fill.
Right, yes,
So
get that, but then we're putting the impervious, so I'm still curious as to, yeah,
so the impervious area too is obviously that's all has been designed so that all of the stormwater that's running off is being treated in accordance with the Connecticut drainage design manual. The buffer is again being improved over the existing condition. You know, the idea that there is some set number of upland review area that needs to be established on the project. You know, that's obviously why there's an upland review area to come in front of the commission to review these. But again, we are providing a buffer that ranges anywhere between on average of 22 feet. The existing condition, again, I keep saying this, but it is grass. We will be vegetating it. It will be an improvement over existing conditions. Stormwater will be being treated over the current condition where it's not being treated. Obviously, the grass environment, it provides very little in the way of infiltration. You know, we're infiltrating the stormwater into the system and then through a level spreader and then through a vegetated buffer before it gets to the stream wetland area. So we do, you know, based on that, we do believe that is an improvement over the existing condition.
okay. And forgot to ask this before, and pardon me if it's somewhere in the plans, but where is the snow removal going to go?
So that either, you know, there's several options, but most likely it would be placed onto the grass area behind the building where it's landscaped, and you know, it's a little bit of a I can pull up the plan. It will just be going into that landscaped area.
And you feel that would be adequate to take up, you know, one of our larger storms?
Yes, and I think the applicant would also be willing to, you know, if it's a very large storm, a lot of times they'll actually remove the snow off site and haul it away.
Right, but then that would become part of the homeowners association responsibility then.
This is going to be maintained as rental units.
Rental units, okay. Sorry, I didn't pick up on that.
But it is very common to actually haul snow off of a tight site.
Anyone else on the board before we move on to the engineering part? Good, okay. Thank you, Mr. Similidis.
Good evening. Andy Sumalides, professional engineer and principal at Lantec. I'm out of Westport. I think you heard Mr. Verbickus' response or our response to his comments and questions, and he seems to be very satisfactory with our responses and on our plan. I don't think there's anything really outstanding that he had on his list of comments, unless I'm mistaken, that we didn't address. And it seems like everything has been addressed. I'm more than happy to go through them if you guys want to go point by point, but it seems like they were all addressed. I will address some of the things that have come up tonight as comments. So again, one of the questions I think is, let me pull up the plan. It's best if I share my screen. So one of the questions that seems to be coming up is this whole area is segregated from this area and we're building a bathtub. And where's this water going? And I think Mr. Verbickus actually had that as one of his comments with the saturated soils beneath the infiltration system, what's going to happen? And it goes back to those weep holes. So in section form here, you could see the bottom of the system, that 36-inch separation, gets into your groundwater, but there was concern about horizontally, where's that water going to go versus vertically. We had a liner put in behind the wall. The purpose of the liner is so infiltration doesn't come out at a higher elevation, and making sure all this soil does go vertically down and get the proper treatment. We set the weep holes down below that 36-inch treatment level. So you get the treatment, water has the potential, the stormwater runoff has the potential to get into the groundwater, as mentioned earlier. Or on lighter storms, it just stays in and then dries out over time. But these weep holes allow it to connect to existing soil conditions on the other side where we have our vegetated buffer. So that's how we're not really building a bathtub, by allowing the waters to, after treatment, migrate towards the wetlands. And these weep holes are 4 feet, 4 inches, 4 feet on center. It's very typical of this type of design. In septic design, it's very typical also when you're building a retaining wall next to a septic system. This is acceptable by the Connecticut Public Health Code for septic design. I know this is not a septic system, but I'm just giving you an analogy of how this operates and works with the weep holes. Another comment that came up was the deep sumps with hoods not providing sediment removal. The 2023 manual specifically states that deep sump hooded catch basins provide a high pollutant removal for sediment, including sediment-bound pollutants and floatables, quote unquote. So the deep sump hooded catch basin, that's probably their biggest pre-treatment function, is the removal of sediments. And that's why we went with the 4-foot deep sump with the hoods in a parking lot, right? That will be, like we just mentioned, snow plowed, and potential of sand being put on there and sediment from cars, migrating onto site. So the deep sump hooded catch basins is one of the preferred methods of the 2023 stormwater manual, the draft manual that we keep referring to. Another question came up regarding the time of concentration. I'll share my screen again and pull up the drainage report. Here's your existing condition P sub C of 17.6. We could use that same theory that Commissioner Pilch said about, not taking this highest point in the longest travel path. So the T sub C is the time of concentration a drop of water falls within that watershed and gets to a point into the watershed. We took this point over all lawn area to get into the wetland system, a time of concentration of 17.6. We could easily take this paved surface, the end of the driveway, flowing over the lawn as a time of concentration also, if that's the theory behind that. When you go to your proposed condition, this whole area, this dark area, is all our impervious surface, the roof and every inch of new impervious surface on our piece of property with a T sub C of 5.0. This little strip here and the wetland system back here and a little bit up here, we got a time concentration of 16.6. So that's a drop of the water that falls here and goes parallel with the building and then gets into the wetland system. This area is 4,591 square feet. You could probably most likely put this at a T sub C much lower if needed, and it won't move the needle in our model. It's not going to change the peak runoff flow. It's just such a small area and it's all pervious surface. If it was an impervious surface, I'd understand, but this is all lawn and grass area that is traveling, and that's the path it takes, the time of concentration for this little bit of area, because this area does not get into our detention system. It travels over land and off our site. So that's regarding the time of concentration comparison. I know Commissioner Pilch wants Mr. Verbickas to look at it as well, but I just want to respond to some of that. The last one, I think, was the 10-year storm. And I think Mr. Verbickas said it as well. The 10-year storm gets up to elevation 202 point, let me pull it up so I have the exact number elevation wise. It is 202.49. So in a 10-year storm, this system roof runoff goes into the gutters, into the underground detention system. Runoff from the parking lot goes into the catch basins and into the underground detention system. And it gets up to an elevation of 202.49. Mr. Pilch said there would be concentrated flow coming out of our system. That won't happen. Our catch basin top is 204.5. So this runoff will sit in the pipe system. It'll infiltrate over time into the soils below. It'll outflow through our outlet here over time and dissipate. So there won't be runoff coming out of this catch basin and concentrated flow going and providing erosion or anything at the surface. This will all stay within the piping system. This catch basin here is at 205. Our roof leaders are up at 205. It's not going to be bubbling out of our roof leaders or our catch basins. It will sit within these systems. And yes, it will fill these pipes up, but it's not coming out of the top of the catch basins. And then it'll slowly infiltrate into the ground over time and then metered out through our level spreader. So there is no point concentration coming out of our system in a 10-year storm. And I think lastly, we keep talking about the percolation versus permeability testing and what's the appropriate practice. We always use percolation tests for sizing of stormwater systems. I bet if you ask Mr. Verbickus or even Commissioner Pilch, if he's used percolation tests in sizing and building detention systems, they both tell you yes. It is a normal practice to do percolation tests. I want to repeat, we did a 1 in 10 percolation rate. That's 6 inches per hour. We use 2 inches per hour in our model. So we use the 1 in 20 at a 50%. So a 2 inch per hour rate in our system. So I know we're keep pointing to the 2023 manual, but I just want to point out there's other things in the 2023 manual that go in the different direction, i.e. there's ways that you don't need 3 feet of separation from seasonal high groundwater. You can have 2 feet of separation. So if we're really going to point to the 2023 manual and that's the guideline, we need to know that so we design appropriately, because then there's other methods we can apply that are actually favorable. I think we're just picking out the things that are detrimental to, in lack of a better word, but there's things in the new manual that actually allow you to do other things stormwater wise that can make it a better plan and less restrictive, I woid say. So if we're going to really point to that 2023 model or that 2023 draft plan, there's other things within that plan. If we're going to point to that document, if we're allowed to point to that document, I'm more than happy to use it and apply it here. I just want to note that there's other things that we may do differently, and it might change the plan to make the system smaller or more separation or less separation from seasonal high groundwater and such. There's other practices you could do to achieve that. So I think that's, and again, like you heard earlier, we're not opposed to doing a double ring infiltrometer. We could do that test and provide that data. And then if we provide that data, I want to use that data, right? So I'm going to use 50% of that data rather than a very, very conservative percolation rate that we've currently used. So if we're allowed to do that, I'm more than happy to do it, but I don't want to just keep getting, pinched down on our system. I want to be able to use real data then that we're saying that, double ring infiltrometer will give us and percolation test isn't, and apply the right factor of safety and use it in our model. So I think that's, it's just, which way do we want to go with them? We're more than happy to provide it. But I don't want to just pick and choose things out of the manual that we want to do now. I think if we're looking at that manual, I want to just look at it in its entirety. Thank you. I'm happy to answer any questions.
Tracy, is your hand up or are you?
It actually is up. Just following up on that last explanation regarding the 202.49. What happens in a 50-year storm?
50-year storm. Good question. Let's see. 50-year storm, 204.55. And the orifice outlet is 0.09 CFS come out of that on a 50-year storm, that catch basin. 0.09 CFS. on a 50-year. So it would bubble out because I think that catch basin is 2045 and the model says 204.55. So you will get 0.09 out of that catch basin.
And could that be a hazard if it freezes in the winter? Is
Well,
it,
again, this is a storm event that will subside, right? So at the peak, that's at the peak. So these, again, we're talking about peak flows. At the peak of that storm, that's what it's going to get to, but then it subsides over time, right? It'll, it goes up to a peak and then it infiltrates, the meters out, and then it goes back down. So at that peak, the water's not going to stay there. It's going to eventually infiltrate into the ground.
I guess that's not a wetland issue anyway, but okay,
Right.
all right, thank you.
Tim?
Thank you. Thank you, Andy. Questions, just some small questions.
Sure.
For the record, I don't have it in front of me. What time of year was the existing perk test data collected as it relates to seasonal high water? I'm sure we had the logs. You provided the logs.
It was in October of 22.
October of 22. Okay. Thank you. Next question. Do you have any concerns, or I'm not familiar with the weep holes that you discussed, but is there any potential for catastrophic failure with them clogging with fine material moving into subsurface?
No, it allows, there's 4 feet on center, 4-inch holes, and it just allows the water to it'll connect the two substrate soil conditions. So no, I don't see that being an issue. There's enough weep holes that the water will be able to penetrate through those weep holes, through soil conditions and to the adjacent wetland.
What would happen if it did fail? Is there any data or possibilities that if it did, what would happen? Prediction?
What happens if the weep holes fail?
Yeah.
I don't think anything, honestly. The weep holes are really, a secondary measure, I would say. It's not like a primary measure to make sure you're getting the proper infiltration. So no, I don't think anything would happen. It's more of a belts and suspenders approach.
Okay. And last question, as it relates to stormwater, specifically on the surface, since we discussed snow melt, but also just surface water runoff, if there's any inundation, the grass area, would that be, would the applicant or your client consider a no-mow area there as well, instead of manicured lawn adjacent to the buffer?
On the upper terrace?
Yes.
I think it's a vegetated, right, Brian?
Yeah, it's a turf grass, but there's native shrubs that are being installed there. We did want to have some green space on the property that's usable by the residents.
All right. Thank you for clarifying. That's all I had.
Thank you. And Chris?
Yeah, hi, Chris Phelps, member of the IWB. I know you addressed this at the last meeting, but I'd like to get my memory refreshed. You had an approved plan of 3 apartments. Now you're at 14. How did you arrive at 14? Why not 10 or 20? I mean, how did you get this number out of everything that you've done?
So we had an approved plan of 5.
Okay, 5, sorry.
Correct. So what we did was work backwards, look at that approval and basically infill between the 2 buildings. And saw that, that was approved. Our plan, and with no stormwater practices, no buffer, and we basically infilled between those 2 buildings. I mean, that's essentially how we got to our design. We maintained that same buffer. We've enhanced that buffer. We've added significant, robust stormwater measures to a plan that didn't exist. So that, that was the impetus of our design, how we got to where we got.
Thank you.
Oh, Tracy, sorry.
And just one last question, sorry to keep asking about this other type of soil test, but I know, Brian, you said that you would be happy to do it. But Andy, you seem a little bit more resistant. And so I wanted to ask you what your resistance is regarding that particular soil test.
No, I just want to make it, a point that percolation test is an industry-wide standard practice of designing infiltration stormwater systems. And I just want to point out the way we got there and the numbers we are using, very, very conservative numbers on that type of testing. But no, we're definitely open to doing the double ring infiltrometer. I'm totally fine with doing that test and providing it to you folks. I just don't want to keep, we do that test comes out more favorable. We start using those results and you guys are going to say, well, how'd your system get so small? Well, we did the double ring infiltrometer like you wanted, and we didn't apply a double factor of safety, like I want to call it, on our percolation test. We're going to use a 50%. Like, I guess, like, if we're going to follow the manual, then that's all I'm saying. And I'm fine using that.
Well, I guess we can wait and talk to our next peer reviewer who recommended it to find out more about why he recommended it. So thank you.
Sure.
Okay.
So at this point, I'd like to get to the public. Caleb, are you ready to go ahead? And we have Mr. Trinkus, who I think would logically speak first, and then we'll go on from there.
Okay.
You have him?
Yep.
Here we go. Here we are. Okay.
Oh, good evening, members of the Wetlands Board. Steve Trinkus for the record. I'm a licensed professional engineer in Southbury, and I've done reviews for the Neighbors Association. Before I get into the comments which I submitted to Caleb over last weekend, I'd like to address some of the comments that have been discussed tonight by the board. A percolation test is not the standard for stormwater management design of infiltration practices. Double ring infiltration test is the industry standard, and here's why. A percolation test we use for septic design because it measures horizontal and vertical movement of water. In the stormwater management world for infiltration, we're only using the vertical infiltration rate for the design because it is very difficult to model the horizontal infiltration rate. There have been groups within the American Society of Civil Engineers working on trying to quantify horizontal infiltration. And these guys are all PhD academic professors, and they're having a very hard time qualifying what happens horizontally. So it's a vertical rate. The other difference is a double ring infiltration test can sometimes be an order of magnitude lower than a percolation test. So if you had a 2 inch per hour percolation test, you could have a 0.2 inch per hour infiltration test. The DEP manual from 04, and I haven't gone through the 2003 one cover to cover, but for infiltration practices, the minimum is a 0.5 inch per hour infiltration rate, which is 1 foot per day. That is why that test is more important. Many engineers do use a percolation test, but it is not appropriate for the design of stormwater management practices. I'm not sure who brought up the question of the retaining wall along the north side, but what's interesting, if you look at sheet 5 of the Land Tech plan set, with the 2 cross sections, you'll see the wall and you see this wide footing. If the wall on the north side of the building is basically 6 inches off the property line, you can't build the wall because the footing goes on the adjacent property. So problem number one. I think Alan's point about the water on the south side of the building, if you look at, again, sheet 2, if you look at the existing and even proposed contours, this water does not go to the wetlands. You look at the angled contours behind the easternmost unit and about opposite the stormwater system, that's discharging water onto the adjacent property to the south. Water flows perpendicular to the contour lines, and it's going to direct right onto their driveway. The site right now is 18 inches to 2 foot higher than the driveway for that property, which I believe is 29 Abbott Avenue. So that southern water is going to go onto the adjacent property, not go into the wetlands. Regarding the weep holes, we've heard several comments, and the weep holes at the bottom, typically behind a retaining wall, you put them there so that you don't get hydrostatic pressure behind the wall, which can cause failure of the wall. There's also, to allow runoff adjacent to the wall, or I should say groundwater, you generally have a layer of crushed stone from the top of the wall tapering down to the back of the footing, so that it's free draining material, so that any groundwater hits the stone, hits the weep hole, and goes out. But if you look at, again, the wall details, the wall cross sections on sheet 2 of the plan set, these weep holes are 3 feet below grade on the downhill side of the wall. They're not going to the filter strip. They are unlikely to go through the soil. And basically, if it saturates the soil, additional water cannot go through it. This system now is set on existing grade. And if we go to sheet 4 of the plan set, you'll see the percolation test, and P3, which is the one in the infiltration area, that actually was done on June 20th, 2003. The other 2 were done in October 7th of 22. However, if you look at test pit 1, which is the test pit within the infiltration practice or the Caltech system, 14 to 32 inches, we have a sandy loam with miscellaneous material. And if you look under the notes, you have glass, brick, ash, and slag. That's construction debris. So it's very porous, because I dug handholds both north and south of this site with permission of my clients on 27 and 29. And I hit similar material on number 27, or I should say number 25 to the north. It was, fairly porous, and that's why you'll get a percolation rate, because there's a lot of void space when you have miscellaneous construction debris. However, the Caltech system now is set on top of existing grade, and there's no notes here whether the topsoil is going to be removed. So the topsoil is the limiting factor for infiltration, and there's absolutely no data submitted by the applicant to show that topsoil layer, which at least the topsoil I encountered on either side of this site, is very silty, very clayey, and has a very slow infiltration rate just by visual observation of that. So that topsoil layer is now the limiting factor for infiltration, not this hole that's 27 inches down in basically a layer of miscellaneous construction debris, as far as that goes. So that's a major concern, that I don't think this system as proposed will infiltrate a drop of water. Now we have on the current plans, which I'm looking at, I guess they were submitted July 10th by the applicant. We now have what's called the isolator row, which is basically one row of the Caltech units wrapped in filter fabric. And that's supposed to trap fine sediments. However, there's no data on the Caltech website or Googling it, doing a literature search for third-party data as to how well it removes total suspended solids. Now, Caltech does have information on their website, which is a lab-based data. Okay, lab-based data does not translate well to the real world. So this, wrapped filter sock basically around the Caltech, there's no provisions of how is the sediment going to get trapped, because it's going to flow into the bottom of the Caltech and, maybe flow out through the sidewalls or through the bottom. We don't know, but there's no mechanism through the Caltech website of how this TSS is going to be removed. Catch basins with deep sumps and hooded outlets based on real world field monitoring is a 9% TSS removal. That's total suspended solid. That is not very high. A 2-foot sump is worse at 5% TSS. So it is not a high degree of treatment in that. Chris Sullivan suggested a tree filter, or I had just glanced at his report today because I was out in the field. Yeah, I think he also kind of suggested rain gardens. Again, based on the soils on the site, rain gardens are not suitable because they're really Class C, Class D soils, and you're not going to get the infiltration. But a tree box filter replacing a catch basin also will not function. Lid systems, low impact development systems, or lid systems like the tree box filter, are designed for that first inch of runoff only from a water quality standpoint. And if all the flows are going to it, you're going to overwhelm the hydraulic capacity of the tree box filter. They're simply not designed to get every drop of water from the site. And I think what we need to really look at is, the recent storm that, whacked Northwest Connecticut and then went up into Vermont, where they effectively had a 100-year event. They had 7 inches or more of rain. Now, the Ridgefield regulations only require detention from the 1, 10, and 50-year storms. But what happens if a 100-year event shows up here? Alan makes a valid point. You've got a backwater condition coming into that catch basin for a 10-year storm and even a 50-year storm. What happens if it's a 7-inch rainstorm? Then you've got lots of problems. Yeah, you've got a lot of flooding in the area as far as that goes. The level spreader does not provide treatments. Level spreaders are a system designed to allow the discharge over a long linear length to not have concentrated flow. That's the purpose of a level spreader. There's been statements by the applicant that the filter strip down or the planted area below the level spreader to the property line is going to provide water quality benefit. Well, there's no analysis of that. And that's one of the biggest issues I have with this plan is there's a lot of statements made that we're going to improve water quality. We're going to reduce runoff volumes. There's no evidence to support the statements. This system of 9% removal in deep sump catch basins and questionable infiltration, whether that'll even occur, we're going to have discharge increased pollutant loads. And as I think Alan pointed out, basically the entire site's impervious between the building and the parking lot. So you're going to have higher pollutant loads. There is a process to evaluate this. I will say that the calculation that's in the proposed 2023 manual is incorrect. It was taken from Massachusetts, and it's an additive formula for removal efficiencies, which is not appropriate because as the water goes through treatment systems in series, the efficiency of the second or third practice is reduced because it's not seeing the entire load going through there. Again, snow storage on that lawn area. Snow storage, especially when you're stockpiling, it can have extremely high pollutant loads, and it has to go through the treatment system. If it's on that lawn area, it's not going through any treatment system. So that's an environmental issue along that line. So now that I've kind of went through those comments, let me just see if I have some additional ones from my response. The test holes that I dug, the first one on 25, I had very silty topsoil in the first 9 inches. Then I had actually 9 to 21 inches was a layer of hard pan, which is typically, it looked like fill material here because from 21 to 30 inches, I was back into topsoil. So we had a fill layer there. And then I had from 30 to 33, before I couldn't dig any further in a pole stole, I was back into compacted hard pan that was very heavily modeled, which is indications of seasonal groundwater. The test hole on 29 Abbott Avenue, the property line is fairly close to the parking lot. So we went 68 feet to the west from the monument that's on the corner. And at that point, the property line was 1.88 feet off the pavement. I was digging a hole 1 foot off the pavement. So I was on my client's property. Again, we had a silty topsoil. We had a common fill. There was a little bit of gravel in it, but it was, pretty hard dirt soil. And then from 19 to 22 inches, again, we had a brown silty compact loam. At that point, I couldn't dig anymore because I had a rock in the bottom of the test, the handhold that I couldn't dig around as far as that goes. I don't think the one test pit the applicant has here is adequate. When you have disturbed soil conditions like this site and their soil logs reflect that, you need to do additional testing to confirm that. And again, I go back to one of the earlier comments that I made, I think the first hearing. In that test pit 1, when you go from 44 to 72, you're into a cobble and black organic layer. That's a typical description of a wetland soil. I believe the underlying soil of this area is a wetland that was probably filled in the 1950s. I'm not saying anybody filled anything, recently, but this is likely a filled wetland. And you really need to test all of these soil layers from an infiltration point of view to make sure water will actually drain through them. On the groundwater recharge volume, they're using a Class D soil, yet on the NRCS mapping, which they submitted, it's a Class C. Well, the Class C soil does have a amount of drainage associated with groundwater recharge volume. It's actually larger than if it's a Class D soil. one of the concerns is they now have the water quality volume being held below the invert outlet of the 6-inch pipe of the system. But let's play devil's advocate. If that water doesn't infiltrate, that storage volume is also not available for a subsequent storm. And as we've seen the past, couple of weeks, we've had days with numerous back-to-back storms. Maybe thunderstorms only last an hour or something, but they are back-to-back. I can tell you, I don't know if it was Monday or Tuesday, in my house at Southbury, where I actually had a rain gauge, in a 2-hour period, we had 1.25 inches of rain. That's a lot of water in 2 hours, and if you get them back to back, if the system doesn't drain down, where's the water going to go? Again, on the, let's see here, the drawdown analysis, and this I've argued in the town of Greenwich, where it's also located. The drawdown analysis is overly simplistic because it's assuming you have a static volume and a constant infiltration rate, and therefore you can figure out a time. That's not how you model infiltration practices. You model infiltration practices using HydroCAD, where you route your hydrograph of your given storm event through it with your outlet structure, with an infiltration rate, and that will tell you, when the water surface drops back down over the course of the entire storm. Because we just don't fill up this Cultic system and the rain stops, and then it infiltrates at a constant rate. Also, if the soil layers are variable underneath this, you might have a spot where it is 2 inches per hour. You might also have a spot that it's 0.2 inches per hour. So it's not a uniform rate disappearing. And that's why that simple drawdown analysis is not appropriate for stormwater management. And just to clarify, these are not only my opinions. I was recently at the end of May at the EWRI, World Water Resources Congress that was held out in Henderson, Nevada. And, on several aspects, I asked other engineers, and these are stormwater experts from throughout the country and actually worldwide. And they all were in agreement that type of drawdown analysis is not appropriate because it oversimplifies what happens in Mother Nature. On the MS4 worksheet, they're basically claiming that, there's no, increase in directly connected impervious cover. If you look at any of their maps, especially the watershed map, this is a textbook example of directly connected impervious cover. It's building, it's parking, all going to a catch basin. That's the definition of directly connected impervious cover. So there is a substantial increase of directly connected impervious cover. There is not a lessening of it. Now, if every roof, if the drains from every roof area were directed to rain gardens or something else, yes, now the roofs become disconnected and the driveway would only be the directly connected impervious cover. But as proposed, this is all directly connected impervious cover. This is a textbook example of that. On the erosion side, I know Ridgefield, from my experience, requires double rows of sill fence. But the bottom line is sill fence does not run perpendicular to contours. If you have to run it on a site like this, you have to do multiple pieces with little upturned wings and maybe 50-foot intervals where the silt fence is parallel to the contour. If you put it perpendicular to the contour, what's going to happen is water runs along that face, gains velocity because there's very little resistance to flow against the silt fence. And then at the bottom, with the silt fence next to the wall to the wetlands, that's where it gets overwhelmed and off you go. Dirty water goes right into the wetlands. So that's a major problem as far as that goes. The fabric tab, there's different details out there. They're saying they're going to turn the fabric a little bit under the ground, parallel to the ground, and backfill it. While that can be done, it's not as good as simply laying the fabric vertically in the trench because it provides a much tighter barrier to it. But as proposed, this plan still does not address water quality. It has not been documented that you will actually reduce runoff volumes, which you heard neighbors, I think the first meeting, of flooding downstream, and this is not going to help that condition. Now I'd like to go back to, I think, Mr. Phelps's comment or question to me earlier. How would I feel with this next to me? And I will couch this and say, I have done many 8-3G. I've done them in Stamford, Milford, Bethel. I've done multiple ones of small scale, maybe not 14 units, but 10 or 11 units. And all the stormwater stuff is addressed. I think I'm an advocate of affordable housing, but it has to work. And in this site, while I wouldn't like a long building next to me like this, I'd rather see a breakup of the buildings or lesser units. But the stormwater is the issue. It doesn't work. Therefore, I would not want this project next to me because I believe it's going to adversely affect the environment. The original approval plan that I think was submitted prior to the last meeting, where there were 2 units or 3 units in the house and they had the 3 units down below, you know what? That's fine. There's plenty of room. You could have done stormwater. Well, actually, you'd have to do stormwater with that because to get your zoning permit today, the Ridgefield stormwater regulations are applicable, even though they had the wetlands permit without stormwater. Today, to get the zoning permit, you'd have to do stormwater for that plan. So there would be treatment, but there was also room on that plan to do treatment. So, you know, in conclusion, stormwater is still a problem. It's not being, water quality is not being addressed, which will change the quality of the water in the receiving stream behind us on Ballard Green. And you're also going to have increased runoff volumes because it has not been demonstrated that you're going to reduce those by the design. Thank you.
Okay, thank you. In the interest of trying to stick as close as possible to the time limit, I would ask at this point, Mr. Carey, are you good with giving us an extension to the next meeting?
Can we address some of that?
Yeah, we would. Can we address some of the comments that Mr. Trinkhouse has provided?
I would prefer if you could do it at the next meeting, give it some thought and come back to us because we've been holding off the public now for 3 meetings. And I would like to give them a chance to weigh in if that's okay with you and you can give us the extension.
Yes.
Thank you. We appreciate that. I think there's enough things that we're going to need to discuss next time anyway. So I appreciate that. And I believe, Caleb, we have a couple more people who've been waiting to speak.
Yes.
Hello.
Hi, thank you for giving me the opportunity. Madam Chairperson, Inland Wetlands Board members, good evening. My name is Aaron Gorman. I live at 41 Gilbert Street in Ridgefield with my family. I'm a licensed professional environmental engineer. I'm very concerned about the proposed development at 27 Abbott Ave and have specific concerns about non-compliance with the town of Ridgefield's inland wetlands and watercourse regulations as it relates to protecting both the wetlands adjacent to the property as well as the residences downstream, downhill of the proposed development, of which our house is included. The intent of the regulations in section 1.2 state, I'm just going to paraphrase quickly, the wetlands and watercourses are interrelated web of nature, essential to an adequate supply of surface and underground water, hydrological stability and control of flooding erosion, to the recharging, purification of groundwater, and to the existence of many forms of animal, aquatic, and plant life. Preservation and protection of the wetlands and watercourse from unnecessary, undesirable, and unregulated uses. It is the purpose of these regs to protect the citizens of Ridgefield by making provisions for the protection, preservation, maintenance, and use of the inland wetlands and watercourses. And one of the numbers is to deter and inhibit the danger of flood and pollution. I mean, that's what the residents are all talking about. The proposed development does not comply with the intent of this regulation, specifically by not deterring and inhibiting the danger of flood and pollution. As mentioned in several comment letters and during the previous public hearing on September 1st, 2021, significant rainstorm occurred, which directly caused flooding of 2 neighboring properties to ours, 37 and 43 Gilbert Streets. These properties are downstream of the creek that runs adjacent to the proposed development and directly through our property and in between the properties of 37 and 43 Gilbert Street. There are 3 main concerns with the proposed development as it relates to non-compliance with the town's regs. The first is that open space on Abbott Ave, and particularly in the uphill sections, is limited and is critical to ensuring that stormwater has a place to infiltrate during rain events. As stated in Steve Trinkhouse's original assessment, the existing impervious area on the site is 3,064 square feet. Under future conditions, the impervious area will be 14,196 square feet in total. That's an increase of 363%. Only 6,489 square feet are being directed to the underground Cultec system. That leaves 7,700 square feet of impervious area that's not being collected. I think we've had some evolution since that information was provided, but still the system is significantly under-designed and undersized. Second issue is the increased runoff from the proposed development will negatively affect the adjacent wetlands and creek, and further impairment of these resources will exacerbate flooding conditions in these areas. I don't understand how an inland wetlands board could grant approval of an application that adds a significant amount of impervious surface to an under-designed system in the heart of Ridgefield's designated local historic district. And the third issue is allowing development within the 100-foot buffer area, which is direct non-compliance with the town's regulations. Section 10.2 states that in carrying out the wetland board policies, the board shall consider all relevant facts in making a decision for application on a permit, including environmental impact of the proposed regulated activity on wetlands, irreversible, irretrievable loss of wetland or watercourse resources, the character and degree of injury or interference with safety, health, reasonable use of property, including abutting or downstream property, and then measures which would mitigate the impact of any aspect of the proposed regulated activity, including ones that would avoid adverse impact or lessen impacts to wetlands and watercourses that could feasibly be carried out by the applicant. Avoiding controlling sedimentation, preventing erosion, assimilating wastes, facilitating drainage, and providing recreation and open space. We don't believe, residents and my neighbors do not believe that the proposed development complies with section 10.2A, and the board can't grant approval of an application that has a significant impact on wetlands and watercourses. Doesn't comply with section 10.2D. Board can't grant approval of an application that does not prevent or minimize pollution or environmental damage. Doesn't comply with 10.2E. The board cannot grant approval of an application that injures, interferes with the safety, health, and the reasonable uses of property, including abutting or downstream property such as ours and the flooded properties at 37 and 43 Gilbert Streets, which would be caused or threatened by the proposed development or the creation of conditions which may do so. I mean, Steve pretty much said all this in his prior testimony a few minutes ago, so I don't have to go into technicalities. I did want to make just 3 more closing comments regarding the Connecticut Deep's Natural Diversity Database. Appreciate that was flagged, that issue. When you look at the mapping, that does have a shaded section directly on top or adjacent to the proposed development. Although the records show that while the developer consulted, they got the automated response letter and then that was followed up on, sounds like there was a glitch there. We believe that a full ecological evaluation should be performed. We understand based on what was provided tonight that there may not be suitable habitat for endangered threatened species on the property, but they are in the adjacent wetlands, which are very limited in the area. And the proximity of these sensitive ecological resources should be taken into account by both the deep and the town before granting any permits or approvals and not just simply screened out. We're also suggesting a multi-season, study be performed. Some of the species that I know were submitted in comment letters regarding turtles and salamanders, aren't always present all throughout the summer and do start to show up again in the fall. So we're asking for, multi-season study there. Lastly, the board and the town should take this matter very seriously, as the town was unable to stop an illegal demolition of a historic property directly across the street from our neighborhood at 8 New Street in 2021. And the town somehow permitted immediate redevelopment of a multi-unit housing consisting of 3 houses on top of where that historical property was demolished without seemingly much objection. The needs of the Ridgefield Local Historic District, which we reside in, and longtime residents should be taken extremely seriously and not be superseded by private developers seeking to profit. There's been many articles opposing this development. They'll continue to appear in the press and in statewide publications, and the community opposition is well resourced and has attorneys ready to intervene in any town approvals on our behalf. I thank you for your time.
Thank you, Mr. Gorman. Anyone else at this time? I don't see anyone else. Caleb?
John West.
Oh, I don't see him anymore. He's
If,
still there?
if any of the neighbors that live adjacent to the property at 29, 23, 27 are available, I'd be curious to ask them a question.
I think Mr. West's hand is down now, so were you still wishing to speak?
Yes,
Okay, please go ahead.
you can hear me?
We can. We can't
Okay.
see you, but we can hear you.
Okay. First of all, I'd like to commend the Wetlands Board for what you do and try to do to protect the wetlands in Ridgefield. My wife and I strongly oppose the proposed project at 27 Abbott Avenue. How often do we hear from a neighbor or town planning, zoning meeting that my property never flooded before that building or that development or that change in landscape was there? The incessant coverage of land in town and surrounding streets by new construction developments is fueling stormwaters and snow melt-off runoff flooding that is untenable. I have lived in Ridgefield for 52 years and have over time observed significant increases in over-the-road and local stormwater flooding borne by overdevelopment throughout town. Over-the-road flooding is clearly a hazard, and flooding with standing water is most likely a health issue. This project, as insignificant as it may seem, is simply augmenting this situation. In the late 1990s, a 0.41 acre tall grass plot of land located toward the south end of Abbott Avenue was developed into 2 lots with a small house on each. The total impervious coverage, buildings and paving of this 0.41 acre plot is 32%. The additional stormwater runoff from this development elevated street flooding to a degree that required the town to curb the east side of the street, curtailing yard flooding, and install 4 additional stormwater catch basins at the north end of Abbott Avenue where it junctions with Gilbert Street. 27 Abbott Avenue is 0.44 acres. The proposal indicates that 75% of this site is covered by building and paved areas. The direction runoff of this site will travel is east downhill to the wetlands and creek. On May 20th of this year, there was a not so monumentous rain event in Ridgefield. 1.5 inches of rain fell in a 7-hour duration. That would be 1,700 cubic feet or 13,000 gallons of water runoff being collected at this site. I'm really perplexed as where all this water is going to go. What retains runoff spilling onto neighborhood properties? What is the field capacity of the proposed infiltration system? What is the rate of absorption into the ground from this system? Does this rate slow as the earth becomes more saturated? How much volume can the earth absorb above the groundwater? And what volume does maximum saturation occur? What prevents saturation onto adjoining properties? And where does the runoff go when maximum saturation is reached and there is another 1.5 inches of rain the next day and the day after that? Considering the potentially huge volume of runoff from storms and continuous rain events, I do not see how this proposed abatement system would be able to comprehensively capture and release runoff at a rate to not have any impact downstream or to neighboring properties. What assurances are offered to guarantee this does not occur? And off topic, this parcel was approved to be developed with a reasonably sized 3-family unit behind an existing house, ergo a 4-unit development. I would tend to believe the owner was aware of this when purchased. A project representative stated that this could presently be constructed. Please do so with my blessings. The town needs housing, except there are far more appropriate locations that would support this extreme density. The delusive formula to establish affordable housing at this site or any site in town is a miss. And to throw the admittedly flawed 830G statute in the face of any residential neighborhood is culpable. What greatly puzzles me is, why would someone desire to pursue a quest that alienates the entire street and a good portion of other residents in the areas? Thank you for listening and hearing.
Thank you very much. Do we have anyone else? I see your hand up, Mr. Klein. We'll come back to you after the public.
I see a hand from the public. You're all set, David.
Good evening, Chairwoman Baker and fellow board members. My name is Jean Konechny. I'm a Ridgefield resident after moving here from Fairfield last year. While residing in Fairfield, I served on the wetland setbacks. You gotta talk louder. I don't know. Can you hear?
Yes, we can.
Oh, they're telling me you can't.
Just speak up just a little if you would.
Okay, thank you. I served on the Wetland Setback Subcommittee of the Conservation Commission, the Flooding and Erosion Control Board, and served as chairman of the Land Acquisition Commission. I was a steering committee member of the Coalition for the Permanent Protection of Kelder Lands, formerly BHC, a founding member of Friends of Open Space, and a board member of Fair Plan, an environmental and open space organizations. In my time studying wetlands and setbacks for Fairfield, I learned a great deal about the complicated interrelationship between the wetlands and the adjacent areas and the need to protect the non-wetlands areas in order to protect the wetlands resource. I respectfully ask that you reject this extreme intrusion into this 100-foot buffer that Ridgefield has established to protect the significant and productive wetlands. This forested wetland contains a brook and it's a continuation of the Kitticut River Greenway, and it's a wildlife corridor just upstream a short distance. This area is also home to many species of wildlife. I personally observed fox, coyote, bobcat, wild turkey, very large variety of birds, bluebirds, tree swallows, pileated woodpeckers, warblers, et cetera, et cetera. I have also observed 2 species of salamander, one of which is in the attached photo, taken just east of the subject wetland. This is either a blue spotted salamander or a hybrid with the Jefferson salamander, known as the blue salamander complex. Both are protected species in Connecticut. I request that a wildlife survey be completed for the IWB to be fully informed prior to deciding on this application on 27 Abbott. The state DEP has listed the Jefferson salamander and blue spotted salamander complex as species of special concern, and the blue spotted salamander as an endangered species. This should be further investigated before rendering a decision on this application. This board should be fully informed before deciding. I just have a picture of my photograph of the salamander. I'm happy to send it in.
Yes, please do submit. If you wouldn't mind just submitting everything that you.
This letter was submitted prior to the last hearing.
Thank you. Then that's fine.
Should I go on? Sorry. The DEP describes conservation concerns about the blue spotted salamander as follows. Blue spotted salamanders are protected by the Connecticut Endangered Species Act and may not be collected or removed from the wild. Populations are threatened by habitat loss and fragmentation and increased urbanization. Certain populations of the salamander are being impacted by a high number of roadkills during the spring breeding season when these animals migrate in large numbers to their temporary breeding pools. Where appropriate, measures to minimize roadkill should be taken, especially where new development is planned near breeding pools. Such measures may include enlarging buffer zones around breeding pools, providing tunnels or culverts for salamanders to cross under roads, and locating new roads away from salamander migration. Change in the salinity content of breeding pools through acid rain or runoff from road salt can affect larvae and newly transformed salamanders. What can you do? Aquatic breeding pools are crucial to many amphibians, including salamanders. Managing temporary pools, as well as buffer zones in the surrounding forest, is extremely important for conserving the amphibians dependent on these habitats. Avoid the use of fertilizers, herbicides, insecticides in your yard. The proposed, proposed development of the site will cause adverse impacts on the wetlands, watercourse, and dependent species, and eventually degrade these fragile resources. From the site plan, the parcel currently slopes down from Abbott Ave, an elevation of 208 feet to the upland review area's 100-foot line at an elevation of 202 feet, down to wetlands flags 1 through 5 at elevation 198 feet, then not shown, but it slopes down to a lower elevation where the brook flows just east of the flag. The upland review area is proposed to be excavated and regraded, elevating the current grade by several feet. And the entire site will be almost completely covered by impervious surface. Of the 14 connected buildings proposed for this 0.44 acre site, 4 units are proposed to be built within the wetlands buffer area, along with an access drive and substantial drainage structures, all located within the 100-foot buffer. The drainage structure is within just a few feet of flagged wetlands. This would permanently and profoundly change the surface and subsurface water flow patterns. Natural systems cannot be replicated by man-made structures. There is a risk of both starving the current system of wetlands and watercourses and of allowing dissolved toxins such as road and driveway salts, car pollutants, lawn fertilizers, chemicals, pesticides, herbicides to reach wetlands, especially if the system is inundated during heavy rains and overflows downhill into the wetlands area. To the extent blasting is required due to exposed ledge and shallow bedrock, the applicant could conduct a comprehensive subsurface hydrogeological survey. This is not the time to relax the protections set forth in our regulations. Climate change is projected to make extreme events, including flooding and drought, more frequent in coming decades. Wetlands provide many ecological services, including flood control, natural floodplain, protection against drought, cleansing of water, and wildlife and pollinator habitat, as well as the ability to store and sequester carbon. Smaller wetlands and watercourses, especially those in densely developed areas, tend to get less attention and have been impaired by overdevelopment over the decades. But per the DEEP in its guidance on upland review areas, degraded conditions should not be used to justify further degradation. These smaller areas provide even more critical habitat functions precisely because of their location in a very developed area. Whether or not this is an 8-30G project is not relevant here, as this board is not governed by zoning laws, but by wetland laws, which were enacted to conserve and protect these beneficial, fragile, and disappearing natural resources. Further, this board is not obligated to assist an applicant to maximize profits by building out this parcel of land. I ask that you hold the applicants to strict compliance with our wetland regulations and that they fully adhere to the 100-foot buffer this commission has adopted. Thank you for your time and attention and your service to our town. Thank you very much.
Thank you very much.
Ma'am, I didn't catch your name and address for the record. Did she state her address?
Can you state your name and address again, since your name isn't on the screen?
Jean Konechny, Konecny, 25 Gilbert Street.
Okay, thank you. Thank you very
And-
much.
We have other people.
I'm sorry, if we do, we'll have to come off to the next meeting. I don't see any hands up, but at this point, we need to move on to our next public hearing. So if we could wait for the next meeting, I'd really appreciate that.
Of course.
We were trying to be done at 8:30. We're well beyond that now. So I'd appreciate if we could continue everything in 2 weeks. That's July 27th.
Madam Chair, if I could just some quick housekeeping that I think will be helpful to make the most of that.
Yes, I did promise I'd get back to you. Yes.
Thank you so
ahead.
much, Madam Chair, and thanks to all the commissioners, our neighbors, and of course, Mr. Sullivan and Mr. Verbicus for taking the time to review our application. Again, for the record, I'm Jay Klein. I'm a partner at Carmody, Torrance, Sandak, and Hennessy, and I'm here on behalf of the 27 Abbott Avenue team. Just a couple of housekeeping items that I think will help us make the most of our continued hearing here. And Caleb, if you look on in your inbox, you should see an email from me confirming that we have agreed to an extension to the meeting on July 27th. I heard some folks maybe talking, about the experts that we've heard from, and I just want to clarify that Mr. Trinkus is not an independent expert that's been retained by the town. He's been hired by some neighbors who are opposed to our project, and that's completely fine. Folks have every right to oppose a project, and we understand that's part of the process. But I think it's worth noting that while Mr. Trinkus raised several questions, almost none of those were raised or flagged by the experts that this commission, or that this board, excuse me, that the town has retained to review the project that we're proposing. We heard from Mr. Verbicus, who had some comments for us that I believe Mr. Sumalides responded to quite cogently. We heard from Mr. Sullivan, who praised the landscaping plan that we proposed. And I think, this evening said that he quite frankly wasn't opposed to the project. We haven't heard any evidence from the town's independent experts that the project will have an adverse environmental impact on wetland, will have a short-term or long-term impact on wetlands, will result in an irreversible or irretrievable loss on the wetlands and water courses. We haven't heard that from the town's own independent experts. So it would appear that our proposal, we think, is in compliance with section 10.2 of the wetland regulations. We haven't heard anything from the independent analysis that would lead to a different conclusion. I raise that because what I want to make sure of is that we as an application team, as a project team, understand what the commission is looking for us to bring to the meeting on July 27th. I understand that we'll be conducting some double ring testing. I think that's something that Mr. Verbicus and Mr. Sullivan said, hey, you might want to do. And as Andy and Brian said, we're happy to do that. We'll provide the invasive species management plan, as Brian mentioned. But I'm not sure outside of those two items what else there is, or if there is something else that the town would like for us to bring to discuss on the 27th. We'd be happy to do so because, like I said, while we've heard a lot from some folks who oppose the project, it seems that from the own independent reviews that were conducted, we appear to be on the right track in terms of compliance with the wetland regulations. So if there are other items that we should come prepared with, please let us know so that we can make the most of that next session.
Okay, yes, and I think there were some questions from Mr. Pilch that actually he addressed to Mr. Verbicus to review. So that was agreed to as far as I understand.
Okay, so we will be providing the additional testing and the invasive planting, and then Mr. Verbicus will have some additional responses as well. And that will be the the focus, I suppose, of our next session.
I would assume so, yes.
Okay. I do see other folks' hands here. If you guys have other, please let us know so that we're ready. Thank you.
Yes, Carson?
Thank you. I'll put my hand down. Carson Fincham for the record, Inland Wetland Board member. Yeah, I appreciate Mr. Klein's intent with pointing out kind of the spectrum of evidence for the independent experts that the board has hired, as well as the obviously interested parties of the applicant and interested parties of the neighbors that have opposed goals or opposed interest in some cases. I don't think it's a fair characterization to say there has been no evidence that the current plan might adversely affect the wetlands. I think it's important for Mr. Klein to understand as well that many of the individuals on the board have great expertise in this area. And we're taking a look at both the applicant's experts, the neighbors' experts, and the peer review experts that we've hired. And we're taking all that information on that spectrum into account in making our decisions. I think I speak for the whole board when I say that. Personally, I think some of my concerns, and one concern that our expert did raise is the recommended 50-foot vegetative buffer. Ms. Miller also mentioned that earlier, and I would kind of second that as a point that if you want to address something by the next meeting, particularly the difference between not just a vegetative buffer, but an undisturbed vegetative buffer, particularly with respect to the overstory, the large trees that are existing on the property. I think development underneath those canopies would be highly detrimental to the existing systems. I think replacing the grass with native species is a great move, but it would be much more detrimental to remove the large trees that provide shade to the wetlands than to have remaining grass there. So I would take a look at that and consider moving these systems further away from the wetlands. And personally, I'm also concerned with the design storm of 10 years being inadequate. I mean, they're flooding, like there's back pressure in the system already with a 10-year. You go up from that, and like Mr. Pilch and others have indicated, there's a high probability of flooding, whether it's the bathtub effect or whether it's just the property in general. I think the adequacy of the design storm for the system would be something that I would like to see addressed as well, because at least my intent, and I think the intent of the board in general, is to make sure that the pollutants, at least with some reasonable frequency, do not get into the wetlands. And I do not have a comfort level with the plans that have been provided and taking into account all the information that I've seen, that the existing plan takes care of that in the existing configuration. Thank you.
Thank you.
Great.
Tracy?
Thank you.
Tracy, I'm sorry.
Yes, I was actually going to, I ditto what Carson said about the 50-foot buffer. That was the question I was going to raise. And also, Mr. Trinkus brought up a question which I didn't understand. So if someone could look at this, he said that the drawdown analysis is not appropriate for stormwater management. I don't know what that means, but if everyone could look at that and address that at the next meeting, I think that would be helpful to my understanding as well.
Great.
Thank you. Appreciate that. So if that's it.
All right, well then we'll see everyone at 7 p.m. on Thursday, July 27th.
That is correct. Thank you very much.
Thanks,
And we
everyone,
are
for attending.
continued through the 27th. And how about try to make it just 5-minute break?
This is Kirk Carr, on the record. Thank you for watching.